Here's another trigonometric identity where we have a fraction as the left-hand side, and we want to make it equal to secant minus 10. Rule of thumb, start with the more complicated side. In this case, for me, personally, fractions are more complicated. Once again, I have not seen or done this question in a while, so let's get going. I'm just going to write this out. Again, I'm going to drop the argument. I'm going to drop the theta, the variable there. I'm just going to focus on the functions themselves because it's assumed that obviously it's going to be theta all the time. Unless there were two, in which case, and in this case there's not. Okay, so 1 over secant plus 10. Again, I'm just going with my gut feeling. Secant is 1 over cosine, and tan is sine over cos. Okay, so I can combine those together in my denominator. So notice how I have a fractions within a fraction, but I can still work with that. So 1 plus sine, and that's all going to be over cos, which is equal to 1 divided by 1 plus sine over cos. And remember, when you're dividing by a fraction, that is the same as multiplying by the reciprocal. Let me bring this up here. So this is going to be 1 times cos over 1 plus sine. Okay, which is just cos over 1 plus sine. At this point, where do you go from here? I have no idea, but I'm going to try something. I want to get cos somehow. I want to get cos in the denominator. Okay, because, and I want a minus somewhere in there. So this is a little trick that, again, with experience, you'll kind of learn. Remember, 1 plus sine, if I multiply that by 1 minus sine, both top and bottom, this whole denominator here, okay, notice that's a difference of squares really, is equal to 1 minus sine squared, which according to our Pythagorean identity is the same as cos squared. My numerator, I'm just going to distribute the cos into the brackets there, is going to be cos minus cos times sine, and that's all over. Remember, when all this is said and done, is cos squared. And I can divide this fraction up, okay, into two component parts. My first term, cos over cos squared, minus cos times sine over cos squared. And I think at this point you could probably see what is motivating me to separate them. Remember, I want two terms on my right hand side, and this kind of pushes me in that direction. And on top of that, I can bring down this cos to 1 over cos. I can cancel one of these coses, becomes sine over cos. Sine over cos is just tangent, and so my final line here is going to be 1 over cos, which is just secant, or SEC, minus sine over cos, which is just tangent, or just TAN, which I'll write here. And that proves our right side. And that ends the proof. Just want to go back, take a moment. So you might be thinking, well, how do I know how to do this? This stuff over here. I mean, you can't learn that. You just learn by experience, by identifying patterns. You build up your intuition, and you just become. You have to be familiar with the trig identities that you know. Okay, the Pythagorean one is really powerful. It works in a lot of cases. I would recommend you always keep that in your back pocket when doing any kind of trig identity with a square or power of 2. Okay, that completes our proof.